No, this is good. You guys, obviously I'm going to have to kind of retread this water on Monday, but you guys will have an advantage for it. And I will expect to watch. So
oh, it's so cute and fuzzy. Can we keep him?
He's my favorite one yet.
Can we buy
So here's what I want to do. Everyone at the back table says, come on. Come on, shut up. You're moving.
Wow.
Come on.
Just for that language, no, I'm not.
Yeah, I didn't ask. Come on, you're moving.
Andrew, you got
So he says.
So he instructs.
Yeah, come on. Okay,
I just need to hear the magic word.
please.
There you go.
Thank you very much. All right, so you guys are good. So today's topic is a really cool one. So we're going to start with something you already know. You guys already know this because we already talked about this last unit, but we're going to get formal here. This is the first time that you've, at least in your high school career, that you've had to do a formal proof.
Oh.
So in math, a formal proof happens when you can show something to be always true. And you can demonstrate that. And there's a certain kind of language that mathematicians use. So the first example we're going to use is with ones you already know, the reciprocal trig identities. And all that means is this. Cosecant x is what? How do we get cosecant again?
1 over
1 over?
sine
1 over cosine.
of
Yeah, and in this case I'm using an x, so it'll be 1 over sine. Just like that. I pointed at you, don't you worry. So 1 over sine x.
I think you're gonna have to reteach this lesson on Monday.
Yeah, well, people are going to listen too. You don't just get to miss, you know? Like if you think, I have no idea, but this is a U-level course, right? If you're in university, you take the day off for some reason, that's fine. Nobody's going to come and get you, but they're also not going to reteach it.
A majority of the people are volunteering for that volleyball tournament.
Even Caleb?
It's all good. Listen, no, Caleb
he
signed
might
out
just
for the
not
day.
be here.
But yeah, listen, people take off time whenever they want. They got to get come up after on their own. Okay, so fill out the next two. Shit. Can I see? Oh, that looks great. Good.
Oh, I did get it right.
Good. Good. Great. So these are what we call the reciprocal trig identities. And
See, Andrew is smart.
for the purpose of what we're doing, we accept these because these are just definitions. The definition of cosecant is it's 1 over sine x. So we can accept this. We can use these to prove other things. And I'm going to write that down. Because these are true by definition. We've just defined cosecant as 1 over sine x. We are saying that's the definition of cosecant. It's 1 over sine. So it's true by definition. Any aspiring philosophers in here?
I'm good with
If you're an
theory.
aspiring philosopher, you don't have to write this. We call this
Too
in,
late.
no, this next part. We call this an a priori truth, or a priori. I've never quite known how it's pronounced. It's Latin. An a priori truth. It's something that we know to be 100% true because we've defined it. There's lots of things we can't know true. There's a whole branch of knowledge about epistemology. But within math, if we say that the definition of cosecant is it's just 1 divided by sine, then that's true by definition. It's true. It is an a priori truth. It has to be true because I'm just saying, here's the word I've made up. Here's what it means. Does that make sense?
So you made up priority.
No, a priori is Latin. Not only did I not make up Latin, I don't speak Latin. But my wife does. I shouldn't speak it, but she can write it and read it.
But everyone can speak Pig Latin.
There you go.
So
We use the
I
Latin
believe you mean
alphabet.
igpe atenle, if I'm not mistaken.
I can speak Latin. A, B, C, D, E, F, G, H, I J, K, L, M, N, O, P.
There's a
That's true.
song.
There you go.
The Teen Titans made a song about
So
it.
now, from this, we're going to use these definitions to prove other things. We're going to use these things that are true by definition to prove that something else is true. We're going to prove this, that sine x over secant x equals cosine x over cosecant x. We're going to use the things we know to prove something we don't know. Now, to be clear, I could go into Desmos and plug these equations in and show that they give me the same line, actually. In fact, maybe I'll do that. I wasn't planning on doing that, but it's not a bad idea. Desmos, beautiful free math. Start graphing. What's the first one I gave you? What over what?
Sine x over secant x.
Okay, so sine of x divided by secant? I do have a secant button, thank God. Okay, and there's that function.
See, can't you just watch that?
And now, what's the second one I gave?
Cosine x over whatever the heck that's c
Cosecant.
cx.
So cosecant x over what? Over cosecant?
Yes.
Okay. Where is it?
CSC.
You have it.
Cosecant
You've all of them.
x. And lo and behold, we can see they are in fact the same. So just using Desmos, I can say, okay, hey, Orlando didn't screw this question up, which, by the way, I made these up in the middle of the night last night. And it's always kind of a fun challenge to make them. If solving them is hard, I find making them even harder. So they work. So now, here's how we're always going to set these proofs up. In the space I've left you, I want you to put a line down the middle, not quite all the way to the bottom. I want you to leave a little space on the bottom for like a therefore statement, but we're just going to divide the page, kind of like that. Once we get a little better at these, we won't always have to physically draw a separator like that. But then I always want you to put up here left side. I know that seems ridiculous, but just right on the top, that's the left side. And on the other side, we're going to write,
Right side.
that's right.
Or you can do stage left. But
Please don't. You'll make it very confusing, unnecessarily so. And here's how these proofs work.
I don't think
We're
the
going
right
to-
side is right.
We're going to take this equation, and we're going to break it in half. Over here, we're just going to put sine x over secant x. We're just going to put the left side of the equation. No equal sign, just the left side of the equation. And on the right side, we're going to put,
Cos x over cosecant of x.
very good.
No, why can we write all the word sign? There's only one extra letter.
You're welcome to. It's not wrong to do so, but by convention, we usually just use the three-letter acronym.
It's also short for social insurance number.
There you go.
But it's another thing.
So the social insurance number of x.
Now, here's what we're going to do. As a rule of thumb, you're going to start with the left side, just because it's the first thing we come to, and we're just going to simplify it. And the first way we simplify
Simple.
is we usually try to get rid of what is uncomfortable when we look at it. We are usually pretty comfortable with sine, cos, and tan.
Yeah.
Well, the x is going to stay there.
Oh.
The secant. In a rule of thumb, I'm going to put like ROT for rule of thumb. Stick to sine and cos. As much as possible, we want to get rid of anything that isn't sine or cos. Okay? What is secant? The definition's up above. Secant is?
ugh, 1 over cosine x.
Okay, so this would become sine x over 1 over cosine x. I don't know why I offset that like that. That was silly. And I'm just going to put an equal sign in front. We're just going to say, okay, that's a way I can rewrite that. Now, this is where your algebra skills are going to come in. If we divide by a fraction like that, what can we do? How can I rewrite this?
You can multiply it out.
Yeah, so I could make this equals sine x divided by 1 over cos x, right? I could write it like that. Okay, that works. And then we know that division of a fraction, what do we do?
You flip it so it becomes a
Okay, so what would my next line be?
Would be sin x multiplied by cosecant multiplied by 1. Right here.
Well, we flip that, right? So it'd be divided by 1, but do I have to write divided by 1? No.
It's just cosecant.
So I'm going to do that. Now, I want to tell you about a shortcut, though.
Oh,
Wherever secant is, see how secant is on the bottom here? I can move it to the top and make it cosine, because it's 1 over cosine. Secant, by definition, is cosine on the other side of the fraction. So if secant's on the bottom, I can put cosine on the top. And if secant had been on the top, I can put cosine
On the bottom.
on the bottom. Does that make sense? Does that make sense? We can save ourselves all that work. That's just simple algebra. If you have a fraction on the bottom of that fraction can always just end up multiplied by the top of the big fraction. Having said that, showing all this work is not bad. Now that I have this down to sine and cos, I'm going to leave it alone. Does that make sense? When we say simplify, usually if we just get it down to sine and cos, we can call it done. So sine x over secant x is the same thing as saying sine x times cos x.
Oh, shit.
Does that make sense?
Yeah.
Starting to rain again. I have to fight the cold.
Oh, no. That's
I
unfortunate.
actually feel sorry for you.
I do too. Now let's look here. On the
Go
right
for it.
side, if cosecant's on the bottom, cosecant is just 1 over,
Can.
perfect. So if cosecant's on the bottom, I can move it to the top and make it
Sine.
fine. Does that make sense? Tell me if that algebra, if I'm rushing that too much. Do you want me to show all the steps again?
It's fine.
We feel comfortable with that? So cosecant x, remember it's 1 over sine x. So what would the next line of this be then?
Cos of x
Yep.
times the sine of x.
Very good.
It doesn't matter because multiplication.
That's
can be
right.
written either way.
And since the order does not matter in multiplication, I'm just going to reorder that. I'm going to say it's sine of x times cosine of x. And now, what do you notice?
That's right. It's correct.
They're the same.
They're
It's
the
like
same.
matching.
And that is always the goal. And here's where this little bit of formalism comes in. And when I say formalism, I'll show you what I mean. There's a way we now like to show that we're done. We say,
Therefore,
therefore,
with the three
no, but very
dots.
specifically, left side equals right side. And then, ready? Mathematicians don't get fancy very often. We tend to like to keep things simple, but there's a little bit of tradition here. A little bit of tradition. And this goes all the way back to Euclid. If you read Euclid's theorems, they were first translated into Latin, and then they were translated into English by way of the Latin. And at the end of each proof, he would write something originally in Greek. But when it was translated into Latin, it was written thus. Quod erat demonstrandum.
Wow.
Cool.
And that literally means
Welcome to Quadrant
which
Demonstration.
was to be shown. Which was to be shown. So we said, like, hey, the left side equals the right side, and that's what I was trying to tell you. Quod erat demonstrandum.
So he's just trying to be a jerk, pretty much.
Like my brother.
No, it's important. At the beginning, we say, use reciprocal identities to prove that the left side equals the right side. And at the bottom, we say, hey, the left side does equal the right side, which was what we were trying to say. And usually, at the end of a proof, we will short form this to
QED.
QED. All right, so at the end of every proof, we put that little piece of formalism.
That was awesome.
Doesn't really sound formal. Sounds more like, from the way he said it, I was right, sucks. He didn't believe me. I was right.
My brother. True. Like I said, my brother.
Again.
It's it.
The nice thing is we can say that
It's
in
like
a way.
the little boy, the end of the little boy that cried wolf. I told you guys, there's a wolf.
There you go. That's basically this. The little boy who cried wolf was like quadrat demonstrated, and then the wolf. So that's unfortunate.
No, you know what I would have done? Don't save the sheep. Let them eat the sheep because no one believed you when you were telling the truth.
No,
And be
because you
like-
were lying earlier.
So it's not the point. When the
It's kind of.
you lied.
In fact, it's the entire point of the story. like you can agree with it or disagree with it, but that is the whole point of the story.
Or
Yeah,
the British are
but-
coming. No, they're not.
Yeah, that's it. Imagine he had been saying that over and over again.
Oh no. That would be bad.
Okay, so here we go. Houston, we have a problem here. Oh, you Joe. Everything's fine, right? Like that would have been. All right,
That would
so
have been okay.
here,
Would have cared.
we're going to do two proofs. The first proof we're going to do is we're actually going to prove that tan x equals sine x over cos x.
Shit.
Wow.
No, it's not, and it's not so bad. So this is what we call the quotient identities. Why quotient? What's quotient mean?
I don't like it.
Something that equals something.
A Latin word that we both don't know yet.
No, quotient you know. Quotient you know. Way back to elementary school math. To find the quotient of two things, you do what operation?
Solve.
Nope, you do a specific operation. Just like the sum is the result of adding, and the product is the result of multiplying. The difference is the result of subtracting. The quotient is the result of... It's the only operation I didn't say.
I honestly wasn't paying
The
attention.
sum is what you get when you add a bunch of numbers together. The product is what you get when you multiply a bunch of numbers. The difference is what you get when you subtract numbers.
Divide.
And the quotient is what you get when you divide. That's right. So the quotient identities, quotient just means that we are dividing. So this is going to be another one of those rules that we treat as true. Once we prove this, we're going to forever know that whenever we have tan x, we can rewrite it as sine x over cos x. But first, before we can use that, we have to prove that that is in fact true. Does that make sense? Once we've proven that something is true, once quod erat demonstrandum, once that which has to be shown has been shown, then we can always use that as an identity. We will always be able to use that tan x equals sine x over cos x in a different question. But first, you have to prove it. So here's how we're going to prove this one. Let's look at this little, the cast rule drawing I gave you over there, the angle in standard position. So we're going to put some angle, and I think I used x here. Did I, or did I use theta? I used x. So we're going to put angle x here. Angle x right in the corner. Really, I should have used, in fact, can we, well, whatever, we're just going to do it. I'm going to put a little angle symbol in front of that. And can we just make all of these angle x just for the purpose of this question? It's going to make this a lot easier. That was a poor choice on my part.
Decision.
It was a poor decision. Because, of course, what axis is this? We have the x-axis and the y-axis. And if we take that angle and make it into a triangle, what kind of triangle does it form?
Right
A
angle.
right angle triangle. So we can label all the sides of that right angle triangle.
Can we?
Yeah, in terms of like if we're doing right angle
The
trigonometry.
hypotenuse equals 1.
The hypotenuse, I'm actually not even going to call it 1. I'm just going to say it's something. It's r. You're right, if we were on the unit circle, we'd call it 1. But I want to prove that this doesn't just work for the unit circle. I want to prove this
All
works
of
for
them.
any angle. So we're just going to call it some letter r. But the opposite, what does it equal?
Some.
Well, we know that because of the unit circle, but specifically it equals, if that angle goes out to the coordinates x, y, the opposite is just equal to the
Why?
y value. Good.
And then the one
And the adjacent is equal to
X.
x. Now, by definition, in other words, as a priori truths, we know that sine of angle x is going to equal opposite over hypotenuse, right? Cosine will equal what? What does cosine always equal?
itself.
What does cosine always equal? What over what? In every case, by definition.
Sine over height.
What?
Sine over height.
Opposite over adjacent.
That's tangent. What's cosine? Adjacent over.
Hypotenuse.
Very good. That's okay.
So
And the tangent of any angle is always equal to, by definition.
opposite over adjacent.
Okay. So this setup, this isn't the proof. These are like the setup conditions. This is what we're accepting as like all of these things are true before we start our proof. Does that make sense? We're going to say that for any angle, we could put it in standard position and say that it'll have a hypotenuse that is some r that we don't know, an opposite that is y, and an adjacent that is x. Is that cool? Everyone's
Yes.
comfortable with that? Okay. Now, here comes the actual proof. Let's go over here. How are we going to set every proof up?
Left side, right side.
Really good. And you're going to see me start to get progressively lazier. I usually just do ls, rs.
That's what I was telling you.
Okay, so let's start with the left side. The left side in this case is the tangent of our angle.
So that's already simplified.
Well, but what I want to do for this one, this proof's a little different than the other ones.
Better than
Let's go to our triangle here. And based on this triangle, what would it be? Tangent is
So it'd be y over r.
y over x. Good. So let's make that, let's just say that that is equal to y over x. Now that is as simple as we're going to get, isn't it? It's two letters, plainly and simply there. Okay.
Maybe if we can get it.
So that is, I think, where we're going to end here. Now I want to stress something here. With these kinds of proofs, you may find that the first thing you try doesn't work. You may have to come back and change this. Spoiler, you're not going to have to this one. But when you get to really doing them on your own, you'll probably try 5 things that don't work, and for some of them, and you want to pull your hair out. Just start again. Sometimes you just got to start again. Try a different thing. Try a different rabbit hole.
I think my mom would tell me I pulled my hair out.
Okay, don't actually pull your hair out. Now, over here, we have the, oh, I won't believe. On the right side, we have the sine of angle x divided by the cosine of angle x. And what I want to do is turn each of those into the fraction. So go back to the triangle. What is the sine of this angle? Of any angle x? Opposite over hypotenuse?
X, Y.
No, y over hypotenuse. I just
R.
picked a
Y
letter.
over R.
It's y over r. So the top is going to be y over r.
Over.
And then the bottom is going to be what?
X over r.
Is that true? Yeah, I think you're right. I wasn't being doubtful. I just. So the bottom is supposed to be cosine, right? Sine is adjacent over hypotenuse. Adjacent is x. Hypotenuse is r. Okay. What would you do next with this?
Can we cancel the R's?
Yeah. Now I want to show it really specifically, just for once. Listen, if you showed canceling the r's, I know that algebraically that works. I just really want to spell it out here. So let's make this just a good old-fashioned division question. Let's say this is y over r, and then instead of making it a fraction, put like the good old grade 3 division symbol, and then say x over r. Let's do that.
But it's just so much work.
I know. We're tough, though. We're tough people.
But canceling would work.
It would, and I would have been happy with it. I just really want to show the algebra here,
Yeah,
but
that's all
I
you're doing.
totally would have
You're
been
showing how we get it.
Exactly. Now, when we have a division sign like this, how do we take division of fractions and make it multiplication?
Reverse the second one.
You flip the second one. So show me that. What will I end up with?
Y over R times R over X.
Very good.
I'm running out of space.
You can go sideways if you want. So now, now we just do it. Numerator times numerator. On top, I would have
YR.
YR, and on the bottom, I would have?
Alright.
Great. And now, we really can see that r divided by r, of course, must be just 1. 1 on the top, 1 on the bottom. And that leaves me with
Y over X.
y over x. And what did I have back over on the left side?
Y over r.
Cool. So we have done yet another proof. And then down here I would say, therefore, left side equals right side, quad erat demonstrated. We've shown what we were supposed to show. We've answered the question. That's really what that QED means. It means I've proven what I was going to prove. I've answered the question. I've done it. I got it
Will you lose
done.
marks if you don't put that on
Yep.
the test? Oh my god.
So now, the nice thing is, we now have 2 things that we can always use. we can always know that tan x is just sine x over cos x. This is always true now, because we just proved it. We just proved that tan x and sine x over cos x are the same thing. So this is now one of our quotient identities that we're always going to be able to use. And I would recommend highlighting that. I can grab some highlighters for you if you want, actually. Because don't worry about highlighting the rest of it, but highlight that. That is one of our quotient identities. And there's two quotient identities. Because if tan x is just sine over cos, what must cotangent be?
Wouldn't cotangent be, no.
Not quite the same thing. How do you make a reciprocal identity?
Oh, wouldn't it be cosecant over secant?
Cosecant, okay, yes, you could do, yes, you 100% could do that. I still want it in terms of sine and cos, though. Though what you just said is true. Like what you just said is really true and actually a very, very good observation. But to make a reciprocal identity, what do we do with the fraction? We just flip it. So if tan is sine over cos, cotangent will just be
Cos over sine.
cos over sine. And in fact, I told you that down here.
And we highlight that.
Yeah, so highlight them. Those are your two quotient identities. And we've just proven that they're true. First one, by doing our little triangle proof, which, by the way, I would never expect you to do a triangle proof like that on your own. Is that true? Yeah, that is true. The proofs we're going to do are all from the identities. So now, and this is all the identities we're going to learn from today. Everything left for today is just practice. As of today, we now have 5 identities that we know are true. And maybe you want to highlight the ones on the front page too, because there's 5 facts that you're going to be expected to use to answer or to do all of the proofs that we're going to do from today. You're going to learn some more identities next week. And then if you take grade 12, you're going to learn a whole boatload more identities.
I'm taking grade 12.
I'm taking
It's all online, though.
Oh, you know what? Are you doing it next semester or next year?
Here.
Next semester?
Well, both are true.
Had a moment. I meant to say first or second semester next
I'm
year,
not
and it
sure.
came out not how I meant it. Not sure, eh? Yeah.
Oh, Mr. Orlando, congratulations on your full-time position.
Thank you. I'm very excited.
We're full-time fifth
Miss Farmer told us.
Yeah, I'm here full time next year.
Let me know what classes?
I don't know what. I know I'm doing A senior math. Now that could be any.
I know you'll help me
Any
with
11 or 12.
functions if I ever have
I'm here.
questions.
Calford's here.
Yeah.
I'm assuming Smith is like a physics teacher, so he must be fine with his senior maths. I imagine Merg even probably. She's science. She must have her senior maths at least pretty good. So between all of us, lots of bodies to help. So these 5 things that we know are true. The reciprocal trig identities are true by definition. Cosecant is 1 over sine. Secant is 1 over cos. Cotangent is 1 over tan. We just flip them all. Those are all true by definition. And then we just proved the 2 quotient identities. Tan x is sine x over cos x. And then, because we know that cotangent is just tangent flipped, we know that cotangent is cos over sine. Those 5 facts are all we're going to need to do the next bunch of questions. And I want to do the first, at least one, together. At least one. So let's try this first one. We're going to use the quotient identities to prove that the cosecant of x times cotan of x, and really a little dot in there might be helpful for you just to know we're talking about multiplication. It's actually not needed. If you write 2 identities next to each other, or 2 ratios next to each other, it's understood they're multiplied. But not a bad idea to draw a dot in. Can you prove that that equals the secant of x? So first of all, I'm going to quickly plug this into Desmos, and we'll make sure Orlando hasn't screwed up. What's the first one I gave you?
Cosecant of x
Cosecant of x?
times tan x.
Oh, what the heck was that sound? Can't define now. Okay, so there it
What are
is.
those?
Isn't that a fun looking, look at that function.
Oh,
Isn't that fun?
no.
I love it.
That is messed up.
Yeah, pretty cool, eh?
That is a road I wouldn't want to
But no, it is periodic, isn't it? It repeats and repeats and repeats. It's a weird one. And repeats in my ear. Don't you know you're a fool? You never can win.
Well,
Use your mentality.
more-
What's this supposed to equal?
It's
Wake up
secant
to
of x.
reality. Every time that I do, just the thought of you makes me stop before I begin. So are they the same?
Yeah.
They are indeed the same.
But this is
By the way, I would advise, if you're ever getting to a question and you feel like you can't do it, check. Go online and check. Make sure it works. Sometimes the textbook screws up. I will never forget my good friend, teacher I used to work with, a lady named Terry Green. She's about 20 years older than I. And she said when she was in university, she was a question checker for a textbook. So one of her professors was writing a textbook. So their job was the professor would make up questions and then have a team of people whose job it was to independently, all separately, answer the question. So in hopes they all come up with the same answer, and then they say, hey, we can put this question in the textbook because the question works, and they all got the same answer. Well, she said the problem was, everyone who got this job of checking the textbook, they were all friends, and she said they used to just go to a pub on a Friday night, sit and have a few drinks and go through these questions. Well, that might not be the most conducive situation to making sure you get independently the best answers, because now you're supposed to have 5 people all doing it independently so that if they all agreed, you knew it was good. And they're sitting in one group and doing it. But don't worry, at least they're drinking.
You mean like drinking red wine while marking tests?
Well, I imagine if they were in a pub in university, probably they were drinking substantially more than I typically drink, which is not a whole lot. So anyway, she said, I totally understand why mistakes slip through, which is to say, sometimes mistakes slip through. Go into Desmos. Make sure they are, in fact, the same. Right? If it says prove this is true, then the supposition is that we're giving you a question that can be proven. If you've spent 2 hours on it and it feels like it's never going to work, check it. Make sure it
I
works.
don't think I've ever spent 2 hours on a math question.
I don't think I ever want 2 hours on a math.
Oh, Lord. I had some university physics classes where, like, it'd be a 2-hour seminar and you'd just do one question. They'd put one up and say, okay, this is what we're working on today, and you'd just go. It'd just be pages of math. And then you'd get to the end and realize you'd screwed up, and then you'd start working backwards, and the mistake would be, like, on the second line of page 1. And you'd go, it's good.
And
Computers,
that's why you lean over. Hey, Rich.
it's
See what
true.
you get.
Lean over and say, hey, Krish.
I don't know. It could be
You don't look for the white guy. Hi, person listening, whoever that is. I didn't mean it.
Wait,
Hi, Mohammed.
Yeah, there you go.
Hi,
Anyway.
Istanbul.
Okay,
Hi,
so
Mustafa.
Hi,
okay,
Dwayne.
okay.
Mufasa. Remember?
Okay.
Mustafa Mufasa.
That part is
I bet
the
he's
old
never
number.
heard that before.
Actually, he has.
Actually, he
We all
didn't.
went to class with him.
I know. I was being sarcastic. Of course, he's heard it before. Okay, I want you to try this one. We're going to use. Now, I said use the quotient identities. So all you're going to need to know to make this one work is that tan x is sine over cos, and the cotangent is cos over sine. Those are the only 2 things you need to know, and you can prove this.
Oh,
Is that true? No. I guess you're also going to have to know. You're also going to have to use the identities from the previous page. So really, use
all
the identities you know. Would be a more accurate thing for me to say. All right, get to it.
No.
Oh yeah, I'm going to do mine. You do yours.
No.
By the way, I made these questions a whole day ago, so I have to figure it out too. This is what I like about these. They're puzzly. But the trick is, try and get things down to what we said on the previous page.
Sine and cosine.
Try and get to sine and cosine. So looking at that right side, it's probably cool. It's probably where we want it.
Oh shit! I already made a mistake. No. Oh,
Oh, I wasn't looking at the right side. I'm stupid. Okay. Never mind. The right side's not cool. You're going to have to do work. I was like, that's an easy question. That's a really, this
That's
makes no
15.
sense. Yeah, I got it. Okay. So,
Yeah, just so I know.
I don't even have a cosine. Wait, on sine, right? Is it? Oh, it's not. Shit.
You don't sound like you're having a fun time over there.
who's not having fun?
Andrew.
Sure is.
Humbug.
Remember, he was the grin.
Hello. How are you?
Go away, Zach.
Don't be rude.
Go away, Tegan.
Don't be rude.
They're rude to me all the time.
That's what I was just saying. Yeah, okay, fair enough. I'm on your side now. I forgot to be on your side, but now I remembered.
I mean, she gave me a dare not to speak all period 3, and we're doing no work.
Done.
Did you get it?
They're equal.
Cool.
It's not that hard.
No, and I mean, they will get trickier than this, but
It's
no,
hard
they're not
because I
hard.
have to keep flipping back and forth. And I don't
Yeah.
like that.
Yeah, it takes some doing, but once you get used to them, they're not so bad.
I don't like it.
Hey, we did the exact same thing.
Did we do it the same way?
Yeah.
Nice, because there's a million ways to do
I didn't
these.
even look at yours.
Oh, I wasn't paying attention.
Good job. Now tell me you've answered the question. Yeah, no, don't pay attention to the screen. Pay no attention to the man behind the curtain.
I knew the
You do your
answer.
own work.
I still just, I don't
Okay.
got it.
Okay, so
I-
listen. This is where that bit of formalism makes a difference. First thing, divide your page in half.
Well, I am.
I answered.
See, I have the line from the other side through there, and I'm
Hey,
using
I
the equal
did
sign
it.
to divide.
So, yeah,
both
we
of them.
don't do that. What we do is we divide the page in half. And on one side we say left side, on the other we say right side.
Yes,
Because the
Mr.
whole point.
Orlando.
But listen, and it's not just me being persnickety, though I am. The whole
You're the
point.
cat from Garfield?
Is that the cat from Garfield?
Persnickety. No, it's the cat that was in the kennel.
That's awesome. I did not know that. The whole point is we separate them from each other.
Oh,
We're
that's
not
cool.
saying they're equal to each other. We're trying to prove that they're equal to each other. And the temptation, if you say they're equal to each other, is to start moving things from one side to the other. Well, that only works if they're equal, which is what we're trying to prove. So you can't prove something by assuming it's true.
Never
That's the
assume
whole
it's
point,
true.
right? So if you start moving things from one side to the other because they've got an equal sign between them, and then at the end you go, hey, I proved it. This is the same as that. Well, you had to use the assumption that they're equal to prove that they're equal. That doesn't work. So we have to separate them. It's like if you've got two witnesses and you want to make sure they're telling the same story, if you're worried that they might be trying to pull the wool over you, are you going to interview them and ask them all the questions in the same room?
No.
So they can hear each other's answers? No, that'd be a great way to get them to lie to you, right? We're going to separate them. This is great. Can I tell you a story? This is probably a fake story, but I want it to be true. I had a first-year university professor who told this story. He swore up and down it's a true story, but I think he's lying. But it's a fun story. He says that he went to MIT, the Massachusetts
We know what it
Institute
is.
of Technology. I don't know. Did you know that?
No.
Well, there you
I
go.
did. That's where Bill and I went.
There you go. So he went to MIT, which
Oh,
is
really? Am I?
a very prestigious school in the States. And he said he went to school with these two guys who were just heads and shoulders more brilliant than everybody. They were in an engineering program, and he said in second year, these guys were just amazing. They knew everything. They got the work instantly. They barely had to try. So he said the weekend before finals, before final exams, everyone's just cramming. And these two guys get in the car, they go to New York City for the weekend, and they just like drink their faces off. They take all kinds of illicit substances, do all kinds of things your grandmother wouldn't approve of. They have just like a wild, lecherous, debaucherous bacchanal in New York City over the weekend while all their friends are back in Cambridge, Massachusetts, studying. And they set an alarm for Monday morning. They don't have to write their exam till 11, so they got tons of time. Well, they both have poured it on so heavily that they both sleep through the alarm. They wake up at 11. Well, the problem is they got to drive to Boston. They go, what?
Got to drive to Boston.
So they get in the car, they drive there, and they get there, the exam's long over. And they find the professor and they say, Professor, like, I'm not going to lie to you. We went to New York for the weekend, but, we were responsible. We set our alarm, we got up. On the way here, we had a flat tire. And we were in the middle of nowhere because we were taking like I-52 up, to
Oh,
nowhere.
I solved it. That was
Good
easy.
job.
That was
And
easier
see,
than I thought.
you did great. And so the prof goes, I totally understand, can happen to the best of us. You two are really bright. No problem. Come back tomorrow at noon, and I won't be here, but my secretary will be, and she'll have the exams for you. You two can sit down, write your exams, hand them in, I'll mark them the next day.
They're going to go drinking.
So they said, okay. So they went. They thought, dodged a bullet there. They show up the next day at noon, and the secretary says, no problem. You know what? I've got lots to do, so I can't keep an eye on you. So I've got you writing in the professor's office, and you can actually write over here in the lounge. So it gets them in the two places, sits them down. They sit down, they open the exam, they put the name on, get the Scantron ready. They flip it over. There's one question. What tire? What tire burst?
Oh, I love this.
To make sure they're not lying.
Yeah. The only question on the exam.
Now the question is, did
Now,
they,
again, I doubt that's a true story, but I really want it to be. But the point being, if you want to get the true answer, you have to separate them. So in the same room, it's going to be going, right? But this way, they're separated.
now the question is, did they both just randomly guess and had the very odd chance of them
Well,
going?
There's a 25% chance.
Exactly. So I was in stats class. So the question, of course, is what are the odds that they guess right? And the funny thing is, you instantly get it. You instantly go, yeah, 25, right? First guy says front left. The other guy has 4 things he could say. If he says the same one, they get it. If he says the other 3, they don't. After a year of stats, you get your head so full of equations and formulas that you want to make the question so much harder than it is. You start doing permutations and combinations and everything you've been taught, trying to figure this question out, and you come up with wild and crazy answers. And the answer is 1 and 4. So it was a great, A, it's a fun story, and B, the prof always told this story and then asked that question and watched every student in the class start trying to do like 3 pages of math, like going nuts, answering, drawing probability trees and this or that. And you were completely right. The answer is 1 and 4. If you assume that they're guessing randomly, right? If you assume that they got the story straight beforehand, maybe it's 100%. If you assume that they go, okay, I have no idea here. Let's think we're driving a car. What's going to make you get a flat tire? Maybe running over a bottle. Where's a bottle most likely to be? Side of the road. Side of the road, well, we were driving in the right lane, right? Like that's where the shoulder is. Shoulder's on the right, so it's going to be on the right. What tire's going to hit it first? Well, the front. Okay, go in front right. You know what I mean? So maybe there's more to it than that, but the basic statistics, yeah.
If they're super smart, then maybe they did guess it right, and they
Well,
told them afterwards.
That's it.
Did he tell you the answer?
Well, he never told. He had all kinds of great stories like this. I should be focusing. I'll tell you my other favorite one he told, because I love this story. And again, it's probably not true, but I want it to be true so badly. I think they're false because it's the same guy who told us all these stories, and they were all so good. Like, how could they be true?
But
He says,
it's something that he probably could do, since he can't give them an actual exam afterwards anyways.
oh, sure. Well, and he's a
He can do
tenured
that.
professor. If you're a tenured professor, you can do whatever you want. My cousin Jen had a tenured professor who said, you can write the final exam if you want, or if not, I'm going bowling. 10-pin bowling. You get 1 ball. However many pins you knock over, that's your mark out of 10 on the exam.
I would think that because I am like pro at
so
bowling.
there you go. Imagine that, strike 100% in the course. That'd be all right. But that was his way of saying, this is what I think of exams. So anyway, the other story this prof told, and I love this, is again, MIT. Said it's a lecture hall first year introduction to mechanics. So that's a course. MIT is the Massachusetts Institute of Technology. So it's engineering is its primary focus. So how many kids are taking first year basic mechanics, i.e. like basic physics of motion?
All of them.
All of them. Huge class, hundreds of kids. So he says it's a midterm, not a final, but a midterm. Because a final you'd be in the room, the examination room with your exam all right out. But the midterm, you're just in the usual hallway, the usual stadium seating, and you're up there and you've got your stupid little, you get like these little side desks that fold over and they're like this big, a piece of paper doesn't even fit on them. You're writing your test on there. It's awful.
I used to know. I went there for the French contest.
There you go. So it's a 2-hour exam. He says at the end, he says, all right, pack up your papers, come hand them in. He said everyone stands up and makes a line, but there's 550 kids in the room, so it's taking some time. So we're moving down the line. And while they're doing this guy is just writing and writing and writing. Prof says, stop. Time's up. Writing and writing and writing. Prof says, sir, everyone else has stopped. They're in line. You need to stop and get in line. Kid just writes and writes and writes. Prof says this like 2 or 3 more times. The kid just ignores him. He's getting mad. The kid's just totally unaffected by this. So there's like 6 people left in line. The kid gets up, goes up, stands in line. It's been like 10 minutes at this point. The kid had 10 extra minutes. And so as he goes up, he's the last kid in line. And the prof says, I'm not taking that. I told you, that your time was up. The kid looks at him and goes, Do you have any idea who I am? And the prof now is really mad. Like, oh, you're like the son of a senator or something. So the prof's pissed off. He goes, I have no idea who you are, and I don't care. And the kid goes, good. Knocks off the tests over, throws it in the mix, and leaves. Again, probably not a true story, but
And what did he knock off again?
knocked all the exams over, threw his down in the mix with the
So
rest of
he
them,
would
and
know
just left.
so he would actually know who's.
Yeah, so good.
Oh, because
Yeah, you have any idea who I am?
I
No,
don't
I have no
care.
idea. I don't care. And the kid goes, okay, good. Whew, I was worried there for a minute. Just knocks him
Well,
off.
if he knew the kid, then the kid would.
Yeah, the whole thing would have really backfired if he was like, Andrew Dominic? Like, no! My plan is ruined.
But what was suck if everybody put their name on the test and he knew everybody else but him.
There you go. Anyway, again, it's probably not a true story. There's lots of polls, right? But it's just a great
I
story.
want that to be true now.
All right, so the next bunch, I've just given you some practice. And I'm going to introduce you to something here we haven't seen. So we'll do one more together, and then the rest I'm going to leave for you to do over the weekend. We'll take a look at them on Monday. But I want you to know something here. Do you see this little sign squared x? The squared's in a weird place,
Such a
isn't it?
sign.
Yeah, here's the reason we don't put it next to the x is that if we put it next to the x, you would think that it is the sign of x squared. Like, hey, take x, square it, now take the sign, right? Whereas what this is telling you is take the sign of x and square
Both.
that. Does that make sense? So I just want to make a little note here that sine x times sine x we could write as like sine x all in a bracket squared, right? Like that would make sense. But every time we write this, do we really want to have to put brackets around it? No, that's stupid, right? So the way we write that is sine squared x.
Couldn't you also just have the x in front of the sign and then square the x?
I'm so sorry. Show me what you mean.
Like you could have it.
No, because it's not that. Like sine isn't a number. Sine is an operation. You take the sign of a number, right? So what this is saying is take the sign of x, and then once you've done that, square it. Does that make sense? It's telling you the order of operations. This means whatever the sign of x is, multiply it by itself. As opposed to, don't write what I'm about to write. Look at the screen. Look here. This would be different. This would mean take x, square x, and then take the sign. Does that make sense? In practice, let's look at the difference between these two things. Let's say x equals 10. Actually, let's do one we know. Sine of y. So let's say sine of 90. Well, that's perfect. Sine of 90. Sine of 90 is equal to 1, right? So let's say we did that here. Sine squared of 90 means take the sine of 90, which is 1, and then square it. So that would be 1 squared, which is equal to just 1. On the other hand, this would mean take the sine of 90 squared. Well, what's 90 squared? 9 times 9 is 81, so this would be 8100. So this would be the sine of 8100. I don't know what the hell the sine of 8100 is. Let's find out. Sine 8100.
Can't do the answer.
Might have to put brackets around it.
Yeah, I think so.
Actually, I don't know if the math in Outlook will, or in Access will, or in, what program is this? OneNote. I don't know if it will do
I can
sine.
try.
Anyway, point being, there we go.
Oh.
Point being, it's a bunch of gobbledygook and it's not 1.
basically 2.
Yes. No, because it's times 10 to the negative 15. It's basically 0.
Yeah,
Um,
I thought 0.
So the point being, sine squared x means sine x times sine x. Does that make sense?
You might want to raise sine 90 in case someone tries to.
Yeah, that's true. We're just going to clean that up. So sine x times sine x, write that as sine squared x. So if we have sine x times sine x, that's the same thing as sine squared x. Does that make sense? All right, with that in mind, I want you to try and solve this one.
Does I have to?
The good thing is, I think that left side, I mean, you can't get more just sines and cosines than sine squared x, right? So that left side probably just wants to be left alone. You okay?
Good brain stuff. No.
There are lots of different ways to do this, so don't look at me. In fact, I just did it a different way than I had done it previously.
Oh, I thought you were doing the exact same thing. How did I do that? I did it on the wrong side to make it same thing. I messed up.
No. Okay, so what you got?
I'm that way.
Yeah, you can do that. So now, what do you do with these?
I flipped them.
Yeah, so there's no reason for cos to stay on the bottom. You're dividing by both of them. So they're both going to flip. Right? Yeah, sine ends up on top. The cos also ends up. Think of it this way. Yeah? This could just become one fraction, right? What's 1 times 1?
1.
Okay. What is sine x times cos x? Well, it's sine x times cos x. So now when you flip it, what goes on the bottom? Just 1. And what will go on the top?
1 times cosine.
That's right. Good.
So what am I doing then? I'm messing up.
I did this wrong
That's okay.
because I did not prove. I got that these all cancel each other.
Okay, so let's take a look. Oh, okay, here's why they don't. Here's why they don't. This, you got to be very careful dealing with fractions over fractions.
Oh.
So this is where we're going to start to want to use some of those algebra skills. Let me walk you through my solution. I said that cosecant is 1 over sine x, right? Which means that if cosecant is already on the bottom, then yes, I could turn it into a fraction where we have 1 over sine x. But if cosecant is on the bottom, then sine x should be on the top. So I can just put sine x on the top, like that. And if secant is 1 over cosine, then if secant is already on the bottom, when I flip it, cosine is going to end up on the top. And that is one of those algebra skills we just want to get used to. Now, you don't have to. What you did there works well. All right? And what you did there works well. All right? So the other thing we could have done, and I'm going to go with you guys, is this. You just have to be careful about it. As long as you're careful, you're fine. But it does take, we have to The only thing with these is it requires new and extensive amounts of caution when doing a question. We got to learn to be very, very careful with our algebra, because a small algebra error can be kind of devastating when you do one of these. So you could say tan x, what? 1 over cosecant x, or 1 over sine x, I'm sorry, right?
I didn't do that. I did
Times
tan x.
1 over cosine x.
Hey, you want a giant class here?
Okay. And then you probably replaced tan x too, and you said this was what? Sine over cos?
Yeah. And I
Sine x over cos, but now you can't just start canceling willy-nilly. You got to be careful. So let's think of it this way. So that's sine x over cos x. Do you find it cool? I'm sorry.
That's the one.
And now we're doing division, right? So let's divide it by 1 over sine x times 1 over cos x. And I'm going to turn that into a single fraction, because what's 1 times 1? 1. What's sine x times cos x? Just sine x times cos x. And now, because we're dividing, this would be sine x over cos x
You're trying to do multiplication, so you
times,
flip the
Yep.
other one.
so sine x times cos x
Over one.
over 1. And now, does anything cancel?
Just the cosine.
That and that. And so what are we left with? Which is just
Sine.
very good. By the way, Andrew, the way you were solving it, you'd already moved the other one to sine x times sine x, so you would want to keep it that way. So there we go. Does that make sense? So we all did it different ways. We were all good, and everything you were doing is good. You just have to be careful with canceling, right? Fractions over fractions is very awkward. So my advice, may I give you my advice? Let me go back and show you how I would have approached this. And let me just walk you through it step by step, because it will save you time in the long run. And it will save you heartache and misery and sadness in the long run. And I want to save you heartache, misery, and sadness. And what I would just say is this. When I flip cosecant, I get what? No, sine. I get 1 over. Flipping it, I get sine. So to flip it, it's already on the bottom. So when I flip it, it's going to end up
On the top.
on the top. I don't have to do 1 over. I can flip it because it's already in a fraction. Think of it this way. It's already 1 over cosecant. So when I flip that, the 1 ends up down here, and what ends up here? Sine x. Good. I can do that. And then when I flip secant, I get what? That's right. So 1 down here, and cos x up there.
Oh, so basically it's just cosecant equals sine and secant equals cosine.
1 over flipped.
Sort of.
Cosecant is sine flipped. Secant is cos flipped. So because they're already in a fraction, because they're already in a fraction, I can flip them right here. And I can flip cosecant up to the top. But when I flip it, it becomes
Sine.
sine. And I can flip secant to the top. But when I flip it, it becomes cosine. So if they're already in a fraction like this, use the fact that they're already in a fraction. Don't make yourself deal with 2 fractions. Now I can say sine x times tan x times cosine x. And now what can I do with tan? Well, tan is,
We figured out that it's sine over cosine.
that's right, so sine x times sine x again over cos x times cos x. And now,
Both of those are over one.
that's right, this is over 1, that's over 1. And what cancels? Well,
The cosine.
cosine and cosine. What are we left with?
Very nice.
Yeah, now again, I can't stress enough. You weren't wrong. What you had was totally correct. But you will find that you make fewer mistakes if you start to let yourself take algebraic shortcuts. And one of the algebraic shortcuts is writing a fraction like sine over cos over 1 over sine times 1 over cos is not wrong, but God, is it confusing. It's very confusing. And it's okay. If you're careful, you won't go wrong. But if you start to know that, hey, when I flip a fraction, the 1's going to end up on the bottom and the cosine's going to end up on the top, it takes a bit of practice. And that's okay. Practice is good for you. But but you'll make a lot fewer mistakes. Does that make sense?
Yeah.
But again, what you had was not wrong. Like, it wasn't wrong at all. I'm not trying to be discouraging. I'm trying to provide potential next steps, potential next ways of doing things. So the rest of these, I want you to practice for homework. And there's some humdingers in here. Look at this guy.
No. So we're going to do 4 people homework.
Correct.
5 people.
No, she wasn't.
Didn't take a lesson.
That's right. Because Monday,
I show up. Okay, I bother to come to this class. No, because like
yeah, good.
sometimes you're my favorite teacher, and sometimes I utterly hate you. I just want you to know.
That's a very rude thing to say.
No, it's not. I said sometimes you're my favorite.
Sometimes I utterly hate you is now not a rude thing to say.
No.
What bizarro universe are we living in? So that's not a rude thing to say to somebody.
I said you were my favorite sometimes.
All right, I'll take that. Anyway, what was the question?
Don't do this.
Don't teach during my class?
Is this a class at this point?
Are we sitting around the table?
Stop waiting.
Yeah.
Go away.
Do you know, Tristan, I decided this morning that I want you to deliver the eulogy at my funeral? I was thinking about this. I think about my funeral a lot. And I've got it all planned out. And this is a new edition where I thought you could start with, like, Dad! Mr. Orlando has died. He was all right. There'll be small sandwiches in the lounge. And then that's it. You can be done. I thought that'd be perfect. That's it. I figure small sandwiches will sell people. I think of that. They'll be like, hey, he was all right, Orlando. He arranged for those little, like, so they cut the crust off. Yeah. Or the method of death, like car accident. Like, I think that could be kind of fun. Just, you know, like.
Today's death
Rochelle Hutter's kitchen knife in the back with a twist. Right? And I'm like, oh, okay. I got it. Anyway.
It sounds like my Apex
I
driver.
think my face is red.
Your delivery of the announcements makes my day every morning.
Andrew's gonna do it next year.